My suggestion from you guys, write this polynomial function with the least degree of real coefficients, standard form that has the given zeros. Make sure you have a page where you have a chance to write down information. Okay? A whole page. Right? Because we're going to be doing examples. Because you have to understand how the pattern is. Okay? Right now, we're going to do an easy problem to start out. This is just an example problem. Okay? If I were to give us a -5, a 2, and a 3. If I said that these right here were the zeros of a polynomial function, and you wanted to build a function based off of those zeros, here's how you could write it. You would write x minus a -5, x minus a 2, and x minus a 3. Now this negative and negative becomes a positive. And then what we would do, I'm not going to do it right here because we're going to do this later. Okay, we're going to do this later. I would have to FOIL out and distribute, use the distributive property and FOIL everything out to get my final answer, which is going to be a cubic function. Okay. If these were the zeros, eventually, whenever I finished multiplying all of that out, that would be your final answer. All right? With the plus, dot, dot, dot. I'm not going to work on that right now because we have more to do. Now, this is where it gets tricky. Because now, you'll notice, well, that's going to be easy because it's going to be the same as, it's going to be an x plus 5. What makes this problem difficult is we have an irrational number and we have a letter I, which represents an imaginary number. So we're going to do another quick example of what you would have to do to set it up. So right now, what if I had a -5, I had a 2i, and a -2i? How would I set that up? We would set it up just like this. F of x equals x minus a -5 become an x plus 5. We would say x minus a 2i and x plus a 2i. What we're going to focus on right now at the beginning of this video is what you can do as a shortcut for this type of process every single time. You've got to have a shortcut. It makes it so much easier. So I want to make sure you understand how to get that shortcut. I want you to use this as your example. A plus bi times a minus bi. And we're going to use something you should already know, which is called the difference of squares. You should already know a certain pattern at this point in your mathematical existence. This is called a difference of squares. What does this multiply together to equal? This becomes an x squared minus a 1. Now, whenever you get a difference of squares, really, all you have to worry about is taking this number and multiplying it to this number. Okay? So you just worry, in the FOIL method, you just worry about just the first terms, okay? Just worry about the first terms, not first, sorry. First. And you simply worry about the last terms being multiplied, okay? Why do we only have to worry about the first and the last? Because if you do the outside, that becomes a negative x. If you do the inside, that becomes a positive. And they always cancel. So let's just know that and not have to do it. So right now, let's just focus right now on the first terms of A. So we know if we just multiply those together, what do those become? A squared. And then I said, don't worry about the outside or the inside, just worry about the what? Just the first and the last. Just worry about the first and the last of the FOIL method because everything else is going to cancel out in the middle. Now, just so you know, a bi times a negative bi becomes a negative b squared I squared. Now I know it's been a while since you dealt with I.
I squared is -9.
Right. So could you guys write this pattern down? I by itself, I by itself is equal to the square root of -1. I squared is equal to -1. I to the third is equal to a negative I. And I to the fourth is equal to +1. Now once you got this pattern right here, that just repeats itself over and over and over again. So I to the fifth lines up here, I to the sixth here, I to the seventh, I to the eighth, and then it just keeps going. Okay? So as long as you know this pattern, you can figure out I to the 100 if you want to. Okay? Because it always repeats after the fourth one. Now, what Zyla was saying was I squared is a -1. So if I squared is a -1, what is a negative times a negative? It's a positive. So what we're going to do, you guys see this pattern right here? This pattern, when you take a plus bi and you multiply it times a minus bi, that will always get us to a squared plus b squared. Now I'm going to give you like 3 examples that your brain will be like, okay, I see how you're able to do this. Okay? So here's what I want you to do. We're going to do 3 examples right now. I want you to do 3 examples with parentheses so you see a pattern. That's how your brain learns. It learns through seeing patterns over and over and over. Now, what I'm going to do is I'm going to do x plus 2i and x minus 2i. I'm going to do x plus 6i and x minus 6i. And last one, let's do x plus, we'll just say 11 and x minus 11. We know all of these are going to be in x squared. This is going to be in x squared. This is going to be in x squared. And when you multiply these together, 2 times 2 is 4. What's I times an I? -1. When we multiply it by negative, that becomes a +4. 6i times a -6i is going to give me a +36. Positive 11i times a negative 11i is going to give me a positive 121. So whenever you get a minus bi and you multiply it by a plus bi, it always becomes a squared plus b squared every single time. That's your shortcut. Okay? Now we're going to use this shortcut to help us with our problem. Okay? We're going to use this shortcut to help us out. Alright, so we're going to go back right here to our problem. So we're going to set it up. Right now, we're actually going to do number 9 now. We're ready to go. We're going to write f of x